ठीक है. So hi guys, we're gonna solve this question, maximum active section trade 1. I've already solved this question a couple of days back as a part of the daily challenge, but I'll just run through this so that it's like a context to the next, which is maximum active section trade 2, which is a harder version of the same problem, which I'll create a separate video on. That's I'm yet to solve that question, but I have gone through that question. But yeah, I wanted to create a tutorial on that, and I wanted to check actually how much time will it take me to actually solve that question, which is why I am creating this video. So let's just quickly go over this question. So what this question says is, you're given a binary string s of length n, where 1 represents an active section, 0 represents an inactive section. Okay, so it's basically a binary string made of zeros and ones, right? So we can have something like this, something like this. Anyways, you can perform at most one trade to maximize the number of active sections in S. Okay, so what they're saying is you can perform at most one trade, at most one, which means you can also say that I don't want to perform a trade, I will just do 0 trades. What is a trade? We'll come to that. To maximize the number of active sections in S. What is an active section? An active section is this, the number of ones. So then basically you want to maximize the number of ones in the string, and to do that you can do at most one trade. Now what is a trade? A trade is convert a contiguous block of ones that is surrounded by zeros to all zeros, and then convert a contiguous block of zeros that is surrounded by ones to all ones. Return the maximum number of active sections in S after making the optimal trade. Okay, lastly, treat S as if it is augmented with a 1 at both ends. So okay, you are saying that it's augmented by ones at both ends. Okay, so first step is convert a contiguous block of ones that is surrounded by zeros to all zeros. So in this example, if we see, we have a contiguous block of ones here, right? But is this surrounded by zeros on both sides? So what it tells us is that assume that it is surrounded by ones on both sides. So there is a 1 here and there is a 1 here. But if you actually read the line, it says that the augmented ones do not contribute to the final count. So these ones will not contribute to my final count, but I will imagine that there are ones on both sides. Why? I'll imagine that where is this color यार? मेरे कलर नहीं मिल रहा यार, ये क्या बात हुई? हाँ, okay, sorry about that. हाँ, तो हाँ, now can I convert this one based on this definition of trade? Convert a contiguous block of ones that is surrounded by zeros to all zeros. Can I convert this to a 0? It is not surrounded by zeros. There is a 1 on its left hand side, so I cannot convert this one into a 0. ठीक है? That is first thing. Secondly, now can I convert this block of 1 to a 0? I can. I can say that convert this block of 1 into 0, right? Can I convert this block of 1s into zeros? I can, because both sides are covered by zeros. So I can say just convert all these 3 to zeros. Similarly, I can convert this or this as, no, this I cannot. This I can convert to 0. This I cannot, because this is not covered on both sides, surrounded by both sides by zeros. Okay. Second step, after converting a contiguous, after that, convert a contiguous block of zeros that is surrounded by ones to all ones. Okay. Now, for example, let's say I go ahead and convert this ones to zeros, right? Now, I can go ahead and convert any block of zeros in this array to ones. So I can go ahead and say that, okay, convert this block of zeros to ones, or convert this block of zeros to ones, or convert this entire block which we have just created into ones. Anything, right? Now, what is the first insight that you get from here? When I have to take the step 2, right? When I have to take my second step in the trade, which is to convert a contiguous block of zeros that are surrounded by ones, I can always make sure that if there is a 0 present in the string, I can definitely convert it into a 1. Why? Because I know that these ones are already present here. So even if all of these numbers are zeros, all of them are zeros, I know that there is a 1 here and there is a 1 here, because that is the augmented assumption, right? So I can convert all of these to ones. But the same is not true for ones for the first step. For the first step, if all of these are ones, I cannot go ahead and convert any of them to zeros because they are not surrounded by zeros. Or even if it is something like this, I cannot convert any of these ones. This is the string, by the way. This is the string. These are the augmented ones. I cannot convert any of these ones to zero because they are not surrounded by zeros, right? So what are the two insights that we get? The first insight is that for the second step, if 0 is present, we can always convert it. Always convert to a 1. Okay, that is the first insight. Second insight is that you can only convert a 1 in the first step. Basically, in the first step, you can only convert a 1 to 0 if it is surrounded by a block of zeros. If there is a 0 block here, then there is a 1 ka block, and then there is another 0 ka block, only then you can convert it, right? Now what does that tell you? Can I say that this string s, let's say this string only, right? So let's just get rid of these things. Right, this entire string s, can I represent it as a vector of which says that okay, there is 1 1, then there are 2 zeros, then there is 1 1, then there is 1 0, then there is 3 ones, then there are 2 zeros, then there are 2 ones, then there is 1 0, and lastly there are 3 ones, right? Can I say that this string s is nothing but this? Correct? Now in this, what are the ones that I can convert to a 0 initially in the first trade? I cannot convert this, and I cannot convert this. I can convert everything else, and I know that it's going to be alternating, right? So if this is a 1, this has to be of zeros, this has to be of ones, this has to be of zeros, and so on. So basically I can say that if I just remove all these ones ka set, right, and I only keep my zeros sets, so 2 of zeros, 1 zeros, 2 zeros, 1 1, 1 zeros, so I know that between all of these there are going to be ones. है कि नहीं? There are going to be ones in between them, and once I convert those ones to zeros, I can go ahead and convert both these blocks to ones, right? है कि नहीं? देखो, let's say I take this block as one group, ठीक है? Then this block is one group, then this block is one group, this block is one group, right? I can say that if I convert all the ones between these two blocks to zeros, then next step I can convert all of these to ones, which means I will gain this plus this as the number of ones. I will gain those many ones in my final answer, है ना? Similarly, if I go ahead and say that I will take these two 0 ka pairs and I'll convert all the ones between them to zeros, and now I'll convert all of these back to ones, so ये तीन तो वापस 1 बन ही गए. These 3 anyways became ones. Additionally, they brought this and this also into the 1 category. है कि नहीं? What does that tell you? That tells you that I want to maximize the sum of these two numbers, and I can only take adjacent numbers at a time, right? So I want to maximize the sum of adjacent zeros which are present. So in conclusion, what can I do now? Let's take an example from them only, right? Let's take this example. ठीक है? So if I just convert this into the fact into a into an array of how many sets of zeros are there. So there is one set of 3 zeros and then there's a one set of 2 zeros. I know that between these two sets there has to be a set of ones. There has to be a set of ones. That's why these two sets are different. Otherwise these two would be one set of 5 if they were connected. I know that there is a set of ones in between, and that means that I can convert that set of ones to zeros and eventually convert these two sets of zeros to ones. Which means that I can go ahead and say that I will add 5 ones to my final answer. So my final answer will be 5 plus the number of ones which were initially present, which is 2. So that's 7. Okay, that is my final answer. Now, how do I solve this? Very simple. I will go ahead and say that I want to make a array of the array of size of 0 groups. Okay, basically, which is to say that what all sizes of zeros are present here, because I know that between those zeros there are going to be ones. I know that for sure, and I don't need to store the size of those ones because I'll anyways get that. I don't care what is the size of the ones that we are converting. It just matters that we are converting a 1 to 0, and then we'll again convert this 0 to 1, and in that process we'll convert these zeros also to ones. That is the idea, right? So what I will say is I will just create a group of 0 groups. So let's say vector of int 0 groups, and I will take what is the s dot length, which is the length of the string. Then I will say simply I is equal to 0, and while I is less than n, what I will do is I will iterate over each letter here. Now if s of I is basically a 1, I do not care, right? If it is a 1, I will just move on to the next. So I will just do I plus plus and continue. However, if it is a 0, now I know that I am starting a new 0 here. What I will do is I will so if okay, let's take an example here, right? So let's take, I have 1 1 0 0 1 0 1 1 1 0 0 0 1 0 0 0 0 0 1 1 1. So let's say my I came here, so it saw 1, it will continue, it saw 1, it will continue, it saw 0 and it will stop. And now what I'll do is I will say start another pointer here. So I is here, start another pointer here, and keep expanding this pointer till you encounter another 1, right? And now I know that this j minus I is going to be the length of my 0 ka group. So why that is that if you look at the indices here, so the indices here are 0 1 2 3 4 5 6 7 8 9 10 11 and 12. Let's take it till there for now. And now if I simply go ahead and say that j will go and stop at 4, so 4 minus 2 is 2, which is the length of this group, right? So what I can do is, so similarly now when let's say when I goes and stops here, right? So I will stop here, I will start a j from here, and I will say the j keep going till you encounter an I. So it will keep, sorry, it will encounter a 1, it will stop here. So 12 minus 9 gives me a 3, which is the length of this group, right? So what I will say is int j is equal to I. Now while j is lesser than n, so you don't cross the entire string, and s of j is equivalent to a 0, simply keep going j plus plus. And now what I will do is 0 groups dot emplace back, or you can even do pushback j minus I. That's it, I guess. Oh yeah, and finally of course I is equal to j. You want to reset the pointer. So basically what I'm doing there is, why I did I is equal to j. So now j stops here. I see that okay, the group is 3. I add 3 to the thing. Now I want to move this pointer to this place. Now I moves here, it sees that it's a 1, okay, move ahead. It sees I is here, it's a 0, oh, okay, now I need to start another counter from here. J comes here, j goes 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 here, and it stops, and it sees that okay, this difference in the indices is 5, so the array, the group size must be 5. Okay, now I get this. Now what I will do is I need to simply find the maximum sum of any two adjacent elements. So I will simply say this size is equal to 0 groups dot size, and now int max answer is equal to, let's say, 0, and for int I is equal to 0, I less than size minus 1, I plus plus, and max answer is equivalent to max of max answer, comma 0 ka groups of I plus 0 groups of I plus 1, and finally return this max answer plus count of s, the count of the number of ones in this array. So now here's another optimization you can do. Instead of doing this here, what I can do is I can simply keep a count of ones here, and every time I encounter a 1, I will say count of 1 plus plus, and finally I will simply say count of 1 here. So that should be enough, and I will just submit this for now, and let's see what happens. And right, so that worked. Now here's another memory optimization that we can do here, right? So you need to ask yourself one question, that here, let's take this array for an example, right? So what are the what is the 0 group that comes here, right? So the 0 group that comes here is 2, then 1, then 3, then 5, and that's it, right? And then I take the sum of every adjacent elements, and that gets me 3, 4, and 8. So I know that the maximum is 8, so that is my answer here. Now, do I need to store all of these elements? Do I need to store? I do not, right? I just need to store what is the maximum sum of two adjacent elements. So while I am calculating the size of this array, this 0 group, for example, so where is this 0 group? So here, right? So when my I is here, let's just get rid of this for a moment. When my I is here and my j is here, and I go ahead and my j stops here now, right? So my j, okay, let's erase all of this nonsense. Okay. Now my j goes and stops here. Now I know that the size of the group is 3. If somehow I just store what was this previous size as 1, I can say 3 plus 1 is 4, and then I can update my final max answer. I can update my max answer to 4, and I can say, okay, now update my previous to 3, and now when I will go here and calculate 5, I will do this 5 plus this previous is 8, so I'll update my max answer to 8, and I will say previous is equal to 5. Hai ki nahi? So what I will do is I will go ahead and say int previous is equivalent to 0 initially, okay? Or rather, let's say -1 instead of saying 0. Now once you're done with this, instead of now pushing back to so we'll just get rid of the array. Now instead of pushing back to 0 groups, what we will do is we will say let's move this max answer up, and we'll get rid of this as well. We'll move the max answer up. Now if previous is equivalent to -1, which means I still do not have a 0 group, I will go ahead and say previous is equal to j minus I. Okay, so rather instead of saying j minus I, let's say current size is equal to j minus I, and we will say this is equal to current size, else what we will do is max answer is equal to max of max answer comma previous plus current size, and previous is equal to current size. ठीक है, बस इतनी सी बात है, हमें तुमसे प्यार है। ठीक है भाई, हो गया, सबमिट कर दो। And if you actually look at the memory optimization that happened, so now it beats 96%. If I show you the previous one which I submitted here, it beat only 41%. So that's a much better optimization. So yeah, I mean, you can see that 81 MB here and here 54 MB, so that's a good memory optimization, and the runtime in fact reduced somehow. Because I mean, of course, you are reducing your array operations, so runtime will also reduce simultaneously. So yeah, that's pretty much it. That's about this problem, maximize active sections with trade 1. The main problem is maximize active sections with trade 2, which I'll be making another video on, and hopefully that's a much more interesting video than this. Thank you.